Climate scientists have an enormous challenge, which is to understand how and why climate varies. Working on TIM and the Glory mission adds yet another dimension to that, which is understanding how the sun changes and how that affects climate. Total solar irradiance is actually a term that scientists have begun to use only really in the last 20 years. Before that, it was called the solar constant. So the solar constant is the integral of all of the energy radiated by the sun at all wavelengths. We soon learned that actually this solar constant varies. So therefore we can't call it the solar constant anymore, so we call it the total solar irradiance, which is really a fancy name for the sun's brightness. Scientists have wondered for hundreds of years how the sun's radiation changed. There was a series of ground-based measurements, and they couldn't determine if the changes that they were seeing were from the sun itself or from the intervening atmosphere. It's important to make measurements of the solar irradiance from space because it's the only way we can measure the variability. The total irradiance monitor on Glory is, at its most basic, a radiometer. It looks at the sun as a star and measures all that incoming energy. The total irradiance monitor on Glory is a state-of-the-art instrument. It has unsurpassed accuracy. So that means we're moving into a new generation of solar irradiance measurements with this higher accuracy and precision. We've recognised that we need to know and monitor the forcings of climate change over a long period. The TIM measurement is crucial in continuing this record of the sun's radiation that we now have covering almost 3 solar cycles. We're now in a period of what's proving to be quite a prolonged solar minimum period. The solar minimum period is very important to measure accurately because one of the big questions for climate change is what happens in episodes of prolonged solar minima. The total irradiance monitor on Glory will be launched at a time to capture this very uniquely long and low minimum. So we're very excited about what the measurements are going to be.